All right, let's jump into the world of software testing methodologies. You know, it's what makes the difference between software that crashes all the time and the kind that it just works.
Yeah, you're right. It's a big deal. It really is the unsung hero behind all the tech we rely on every day.
I mean, think about it. All the apps on our phones, the websites, even things like traffic light systems.
It's everywhere. All of them depend on rigorous testing to work the way they should.
Okay, so testing is like the quality control for software.
Exactly. And it's a whole different thing from actually developing the software.
Ah, so it's not the same as coding.
Nope. Developers build the software, they write the code that makes it tick. But testers, well, they come at it from a different angle. They're trying to break it, basically, to find the hidden flaws before they cause problems.
So it's kind of like a battle between the creators and the destroyers then.
Haha, in a way, yeah. But it's a good thing. It's that back and forth that leads to better software in the end.
Okay, so how did this whole testing thing even get started? Was it always such a critical part of software development?
Well, back in the early days, like in the 70s and 80s, it wasn't really a big focus. But as software got more complex and started being used in more critical stuff, people realized, like, hey, bugs can have serious
You
consequences.
mean like crashing a spaceship serious?
Exactly. Think about those early space programs. They couldn't risk software glitches messing up their
Right,
missions.
high stakes.
So places like NASA and the University of Maryland, they were some of the first to really research how to test software systematically and make sure it was reliable.
So testing went from a side gig to like mission control.
Exactly. And that's when different testing methodologies started popping up.
Okay, so what are some of the main types of testing methodologies?
Well, two of the most basic ones are what we call black box testing and white box testing. Imagine you have a box, but you can't see inside. Black box testing is like interacting with that box, pushing buttons, pulling levers, seeing what happens. You test the functionality without needing to know how it works internally.
So that's like using an app on my phone. I don't know the code, but I can see if it does what it's supposed to.
Exactly. And there are different techniques within black box testing, like equivalence partitioning and boundary value analysis.
Okay, now you're just using big words to confuse me.
No, it's not that complicated. Equivalence partitioning is about grouping similar inputs together. Like if you have a field where you enter your age, you would test with different ages within the valid range and then also with ages outside that range. It helps make sure the software can handle different inputs correctly.
Right, so you're looking for like the sweet spots and then the edge cases where things might break. What about boundary value analysis?
That one focuses on those limits, the boundaries where the software's behavior might change. So, sticking with the age example, instead of just testing 25 or 30, you'd also specifically test 18, which is the lower boundary, and maybe a 120, the upper boundary.
Ah, I see.
And sometimes you even test values just outside the boundaries too, like 17 or
To
121.
see if it freaks out.
Yeah, exactly. It helps find those unexpected issues.
Okay, that makes sense. So what about white box testing? Is that where we finally get to open the box?
Yep, white box testing means looking at the actual code. You understand how it works and use that knowledge to design your tests.
So this is more for the coders out there.
Pretty much. Some common techniques for this are basis path testing and loop testing.
All right, break those down for me.
So basis path testing is kind of like mapping out all the different routes through the code. You make sure each one is tested thoroughly.
So it's like planning a road trip and making sure you hit all the important stops along the way.
Yeah, that's a great analogy. And then loop testing, that focuses on those parts of the code where the program repeats certain actions.
Loops can be tricky, right?
They can be, yeah. If they're not written properly, they can cause all sorts of problems.
Like those infinite loops that make your computer freeze.
Exactly. So we got to make sure they don't spiral out of control.
Gotcha. Okay, so we've got black box, white box.
Mm.
Are there other types of testing besides those two?
Oh, there are tons more. Especially as software has gotten more complex, we've had to come up with new methods.
Like what? Give me the cool cutting edge stuff.
Well, one that's gaining a lot of traction is model-based testing.
Ooh, that sounds fancy.
It's pretty cool. So imagine you're testing a self-driving car. Instead of physically driving it through every possible scenario, which would be impossible, you create a virtual model of the car and its environment.
Like a digital twin.
Exactly. And then you can use that model to simulate all kinds of situations, different traffic, weather, pedestrian behavior, anything you can think of.
So you can run thousands of tests without even needing a real car.
Pretty much. It's super useful for really complex systems where the consequences of failure are high.
Right, like self-driving cars or medical devices.
Exact.
Okay, so black box, white box, model-based. What else is there?
Well, there's also fuzz testing.
Fuzz testing, isn't that where you just throw random stuff at the software to see what happens?
Yep, that's the one. It's kind of like stress testing a bridge, but for software. You bombard it with random inputs, weird data, even stuff that's deliberately messed up just to see if it breaks.
Like a digital torture test.
Yeah, you could say that.
Yeah.
It's really good at finding those unexpected vulnerabilities, the weird edge cases that you might not find with other testing methods.
It's like trying to break into a safe by trying every possible combination.
That's a good way to put it. Fuzz testing really pushes the boundaries and sees if the software can handle anything you throw at it.
So it's good for security testing.
Absolutely. It helps make sure the software is robust.
Okay, so we've covered a lot here. Black box, white box, model-based, fuzz testing. It seems like there's a whole toolbox of testing methods out there.
There is, yeah, and we've only just scratched the surface.
So how do you decide which one to use? It seems like it would be hard to know where to even start.
It depends on the software you're testing, the risks involved, and the resources you have available.
So there's no one-size-fits-all approach.
Nope. It's all about finding the right tool for the job.
Okay, so what about the state of the art in testing these days? With software getting more complex all the time, how are we keeping up?
It's definitely a challenge. We're seeing more and more reliance on automated testing tools to handle the sheer volume of testing that's needed. But at the same time, we still need skilled human testers who can think critically and creatively.
So it's not just about replacing humans with robots.
Not at all. It's about finding the right balance. Automation is great for those repetitive tasks, but it's the humans who can really understand the nuances of the software. The user experience, the potential risks.
Right, because even the smartest AI can't replicate human intuition.
Exactly. And as software keeps evolving, the field of testing needs to keep innovating to keep up.
It sounds like it's a constant game of cat and mouse.
It is, but that's what makes it so interesting. It's a field that's always pushing the boundaries, always demanding new skills and new ways of thinking.
So anyone out there who loves a good challenge, software testing might be the field for you.
I'd say so. It's intellectually stimulating, always changing, and incredibly important in today's world.
Well, my brain's already getting a workout just thinking about all this.
That's a good sign. It means you're ready to dive deeper.
Lead the way. I'm eager to learn more.
Okay, so let's talk about how all this testing stuff actually works in the real world.
Yeah, good idea.
Yeah.
Like, how do developers actually use these methods to make sure their software is, top-notch?
Well, one area where testing is super important is in mobile app development.
Oh, yeah, totally. I mean, we use apps for everything these days.
Right, exactly. And there are millions of apps out there, so the competition is fierce. Users have high expectations.
For sure, if an app is buggy or crashes all the time, I'm deleting it.
Yeah, me too. So developers need to make sure their apps are really polished.
So how do they do that?
Well, one key thing is customer testing.
Customer testing.
Yeah, it's where you release a beta version of the app to a small group of users, and you get their feedback before the app is released to the public.
Ah, so it's like a test run with real people.
Exactly. And what's interesting? A lot of times, users find issues that the developers completely missed.
Really? But they built the app? How could they miss stuff?
Well, developers have a kind of a different perspective, right? They know the code inside and out. They know how it's supposed to work. But users, they come at it with fresh eyes. They might use the app in ways the developers didn't anticipate.
That makes sense. It's like when you proofread your own writing, you might miss obvious mistakes.
Yeah.
But someone else can spot them right away.
Exactly. Customer testing is all about getting that real-world feedback.
To make sure the app is actually user-friendly.
Exactly.
Okay, so that's one example of how testing is used in practice. Are there other examples?
Oh, yeah, tons. Think about the financial industry. They rely on software for everything. Trading, risk management, customer transactions.
Stake stuff.
Definitely. Accuracy and reliability are crucial.
Yeah, a bug in a banking app could be a disaster.
Exactly. So in finance, you see a lot of white box testing, where they really dig deep into the code to make sure every calculation is correct.
So they're looking for any loopholes or vulnerability.
Right. And then you have industries like healthcare, where software is used in medical devices and stuff.
Wow, yeah, that's even higher stakes.
For sure.
Yeah.
In healthcare, you often see a combination of testing methods.
Mm-hmm.
White box testing, model-based testing, even fuzz testing.
To make sure the software is super reliable.
Yeah, when lives are on the line, you can't take any chances.
Right, of course.
So the specific testing methods you use really depend on the industry and the risks involved.
So it's all about finding the right tools for the job.
Exactly.
Okay, so we've talked about different testing methods, real-world applications. What about the future of testing? Where do you see things going?
Well, one big trend is what we call agile testing.
Agile testing.
Yeah, it's about integrating testing throughout the entire development process.
So it's not just a separate phase at the end.
Right. It's more iterative. Developers and testers work together more closely.
So you're catching bugs earlier and more often.
Exactly. And agile testing often involves a lot of automation.
Automation.
Yeah, where tests are run automatically whenever changes are made to the code.
So you can make sure new code doesn't introduce new bugs.
Right. We call those regressions.
Regressions, oh, those are the worst.
They can be? Yeah.
It's like when you finally get rid of a pesky mosquito, but then it just keeps coming back.
Uh-huh. Good analogy. So agile testing and automation, those are two big trends right now. And of course, we can't forget about artificial intelligence.
Oh yeah, AI. Is AI going to take over all the testing jobs?
No, not quite. It's more about augmenting human capabilities. We're already using AI to analyze code, find vulnerabilities, even generate test cases.
So AI is like a super-powered testing assistant.
In a way, yeah. It can help us test more efficiently, find more bugs, and create more reliable software. But even with the most advanced AI, we still need humans.
Why is that? I thought AI was supposed to be, all-knowing.
Well, AI is great at finding patterns, but it doesn't have the same understanding as a human tester. It can't fully grasp the context, the user needs, the business goals.
So it's still the humans who decide if the software is actually good.
Exactly. And that's why testing is not just a technical thing, it's also a human-centered thing.
Right, it's about understanding how people will use the software.
Exactly.
Okay, so we've talked about a lot here. The past, present, and future of software testing. It's clear that testing is a crucial part of making good software.
It really is. And as software becomes more and more integrated into our lives, testing is only going to get more important.
Okay, well, before we wrap up, I have one more question. We've talked about how testing is different from software development. But how do they actually work together?
That's a great question. It all comes down to collaboration and communication. Developers and testers need to work hand in hand.
So it's like a partnership.
Exactly. They both bring their own expertise to the table, but they need to work together to succeed.
And when that partnership works well, you get great software.
Exactly. Software that is not only technically sound, but also meets the needs of its users.
That's a great point. Okay, so we've talked about all sorts of different testing methods and how they're used in different industries, but there's one more thing I want to touch on before we wrap up.
Sure. What's that?
Well, we've talked about how software is everywhere these days and how bugs can have, some pretty serious consequences, especially in things like healthcare or transportation. But what about the ethical side of things?
Oh, that's a really important point. It's something that more and more people in the testing world are starting to think about.
So it's not just about, making sure the software works technically. It's also about making sure it's used responsibly.
Exactly. Like, does the software have any biases built in? Does it discriminate against certain groups of users? Does it protect people's privacy?
Those are really important questions.
They are. And that's where the idea of ethical testing comes in.
Ethical testing.
Yeah. It's about making sure the software we create aligns with our values,
Yeah.
that it doesn't, make existing inequalities worse or create new ones.
So it's about, the social impact of software.
Exactly. And it requires a different way of thinking about testing. Testers need to be aware of these ethical considerations.
Right. It's not just a technical challenge anymore.
It's not. It's a social and philosophical challenge, too.
It sounds like ethical testing is going to be a really big deal in the future.
I think it will. It's about, shaping the future of technology and making sure it benefits everyone.
Okay, well, I think that's a great place to wrap up our discussion on software testing methodologies. We've covered a lot of ground. From the technical stuff like black box and white box testing to the more human-centered aspects like usability and ethical considerations.
And hopefully our listeners have a better understanding now of just how important testing is in making software that's not just functional, but also reliable, safe, and ethical.
I know I've learned a lot, so thank you to everyone for joining us on this deep dive into the world of software testing.
It's been a pleasure. And remember, no matter what industry you're in, software quality is everyone's responsibility.